Durban is located on the east coast of South Africa, in the province of KwaZulu-Natal and in the municipality of eThekwini. It is the third largest city in South Africa and the busiest port in Africa. Durban is also a major centre of tourism due to its warm subtropical climate and beaches. The population of the eThekwini municipality is about 3.5 million people. Approximately 1 million live in townships. Approximately 1.3 million live in shacks in slums and rural areas, 800,000 of which live in extreme poverty. There are 35,000 ventilated improved pit or VIP latrines within the eThekwini municipality. The pits are filled at fast rates, necessitating emptying every 3 to 5 years. This service is provided by the municipality through pit emptying contractors. There are about 360 community ablution blocks or CABs in eThekwini municipality, installed in densely populated townships and informal settlements. Each facility services about 80 households and is commonly connected to the sewage system. Where this is not an option, for example in the rural areas, the fecal sludge can be collected in septic tanks or ventilated improved pits. There are approximately 80,000 urine diversion and dehydration toilets, or UDDTs, in eThekwini. Households are responsible for emptying the sludge from the standing vaults at intervals of 6 to 12 months. The intention is that they bury the dried and aged deposits in their gardens. Nutrient recovery from urine is optional for the users. The UDDTs are well accepted by users in some areas, yet not well accepted in others. The main reason for the latter is that households have to empty the vaults themselves and handle the fecal sludge. In eThekwini, poor flush toilets are still not very common, as this type of sanitation facility is relatively new in South Africa. A research study on 25 poor flush toilets with modified design, including a seat pedestal rather than squatting, indicated a good level of acceptance by users. A further advantage is that they operate with only 1 litre per flush. Currently, 1,000 units are being installed in areas in the municipality. There are about 400 VIPs in rural schools. The toilets may also be connected to septic tanks, decentralized wastewater treatment systems, or DWATs, or to the sewer where this is possible. Unimproved pit latrines have been built by households in townships and informal areas. They are not serviced by the municipality, as they are an environmental and health hazard. They are usually structurally unsound, unlined, and at risk of collapsing.
All the stuff that we need for field sampling. So we have buckets for containers where we're going to put the sample. Then we have gloves, and then we have 70% ethanol, then we have paper towel, and that's we have overalls. And then in the packet there's some additional plastics for covering all the containers. And these are dust masks. Okay, this is Springfield site. So for today we're going to be collecting all the samples from this site. Okay, so we've selected different samples from the pit according to the diagram here. So number 1 is selected from the front. So we have number 1, 2, 3, 4 all in the front side. Then we have 5, 6, 8 at the back. So you first remove the first layer, then you take 1 and 5, you remove the second layer, and you take the corresponding one up until the last layer where you take 4 and 8 from the bottom of the pit. Yeah.
Commonly, users dispose of solid waste products in VIP pits, which results in faster filling rates and blockages or breakages of pit emptying machines. In order to characterize the amount and type of materials disposed of in pits, a study was carried out on the contents of different sanitation facilities. The contents were classified as follows: organics, mainly fecal matter; textiles, menstrual products and nappies; light plastics, hair extensions, stiff plastics; stones, glass, wood, sponge, paper, and metal. It was found that the most prevalent category was the organics, making up between 85 to 95% by wet mass. Sampling of a UDDT is performed for research purposes. Before sampling, the plate at the back of the toilet is opened. The design comprises a double storage compartment or vault system. The feces are collected in an active vault during use. When this vault is full, the pedestal of the toilet is moved to the other vault, which is then the active one. The previous vault will now be inactive or standing, and the sludge inside will slowly stabilize by decomposition and drying. Fresh sludge is sampled from the active vaults of the toilet. Dry sludge is sampled from the standing vault. Where applicable, samples are selected in different layers of the sludge, or at least at the top and the bottom of the vault. The fecal material is put in a plastic bag and placed inside a bucket. Note the importance of the personal protective equipment for safe sampling.
The unique feature about our activities is the laboratory which we have, which we can use to analyze and characterize fecal sludge and excreta streams. This laboratory has built up over many years and many people were involved in building it up. But our great injection came when we started to receive funding from the Bill and Melinda Gates Foundation, first and foremost we had to secure the health and safety aspects and access to the laboratory, and that has been done through funding from the foundation. We've also become a lot more professional in that we have technicians that are able to help other people undertake their work, and we're developing standard operating procedures which we share with other people who undertake fecal sludge research around the world.
Hi, my name is Marlene Reddy, and I'm the lab technician here in PRG. I'm responsible for the general management of the lab, and I oversee researchers, students, and analysis carried out here. And I'm actively involved in the health and safety of the lab.
Our technicians and Merlene, our laboratory manager, now travels fairly extensively, assisting other people in training and getting their laboratories up to standard. At the same time, people come to our laboratories to be able to work with excreta.
The laboratory follows safety procedures as per the OSH Act and the university regulations.
The laboratory complies with all the emergency requirements and regulations for a safe work environment and risk prevention. Wearing appropriate personal protective equipment, or PPE, is necessary before undertaking any laboratory activity. The compulsory PPE when working with fecal sludge is safety glasses or face mask, a dust or fume mask, lab coat, nitrile gloves. When necessary, these should be resistant to sharp objects, and closed safety boots or shoes.
It is very important for the laboratory to keep a record of all the samples coming in, and this sample receipt form helps us to keep track of all those samples. This form is filled out by the person bringing in the samples or by a technician receiving the samples. Pollution Research Group has a number of standard operating procedures which helps us to maintain good quality of work in the lab. And our standard operating procedures range from sampling activities, testing of samples in the lab, and disposal procedures. You can view all the latest versions of our standard operating procedures on the PRG website.
After being delivered from the field, the samples must be properly labelled and recorded. Then they are placed in a cold room at 4 degrees Celsius in order to limit chemical and biological transformation of the samples. For each experiment, a desired representative fraction of the sample must be taken from the container. Prior to some of the analyses, different operations such as mixing, blending, and dissolution must be performed in order to obtain a homogeneous or liquid sample. Moisture content analysis is performed by weighing the mass of the sample after placing it in an oven at 105 degrees Celsius for 24 hours. The ash content is determined by weighing the mass of the sample before and after incineration in a muffle furnace at 550 degrees Celsius for 2 hours. The concentration of components such as ammonia, nitrates, nitrites, and phosphates is measured in a spectrophotometer after adding a chemical that gives a given color to the solution. The concentration of elements such as potassium, phosphorus, calcium, magnesium, and sodium is determined in the microwave plasma atomic emission spectroscopy analyzer. The carbon and nitrogen content of the sample is measured in a CN elemental analyzer. The organic content of the material is estimated by a closed flux chemical oxygen demand, or COD method. An excess of a potassium dichromate solution is added to the sample, and the mixture is placed in a microwave oven so as to oxidize the organic content. The COD is reduced from the titration of the remaining oxidant concentration. The calorific value of the sample is measured in a calorimeter bomb. Thermal properties such as heat capacity, thermal conductivity, and thermal diffusivity are measured in a TCI analyzer. The gas chromatograph provides the composition of biogas from biodegradation processes. The particle size analyzer can provide the particle size distribution within a sample. The stiffness or the penetration resistance of a sample can be measured by a cone penetrometer. The rheological properties of the sludge are characterized by a rheometer. Counterplate tests are performed in order to determine the concentration of E. coli in a sample. The microscopic examination and enumeration of Ascaris eggs determines the concentration and viability of Ascaris eggs in the sample. This analysis is performed by a partner laboratory. On completion of the experiments, the samples are disposed of in a sink connected to the municipal sewage system. The used material and vessels are meticulously cleaned and disinfected. Good cleaning and disinfection are essential before leaving the laboratory. The results from the experiments are captured, analyzed, and stored in a database.
PRG provides support and service to all our partners and associated researchers. The lab also helps postgraduate students with their studies and experiments. The lab houses a variety of equipment. Some of the equipment that we're really proud of are the CNS analyzer, the elemental analyzer, and our GC. We provide training on many of our equipment and requested operating procedures. Researchers requiring analysis and support are directed to our website, where they get guidance on and information on accessing our laboratory facilities. And the lab is open to collaborations and sharing knowledge and experiences.
In eThekwini Municipality, there are different sanitation systems appropriate for rural, urban, and peri-urban contexts. Their management, although provided for by local government, can be very challenging. User acceptance and ownership play a significant role in the daily maintenance and use thereof. Further understanding of how to improve on-site sanitation systems and therefore improve this service can be obtained from knowledge of sludge characteristics and their variations. Consistent sampling is essential for comparability and validity of the results. During the laboratory analysis of fecal sludge, the importance of having risk assessment, health and safety, and standard operating procedures in place cannot be overemphasized. Standard methods and procedures for each step of the characterization process must be in place.